as much as the potential of the frozen zoo was in our minds and prescient, the impact of seeing an animal that was produced from a cell that we banked 30 years ago, or one of the Przewalski's horse samples that was routinely collected as part of an effort to bank genetic diversity, to see that come to fruition is an astounding experience.
Hello.
Hey, Doc, how are you?
I'm very good. How are you?
I want to know about those beauties behind you. I noticed you were changing your screen background.
Yes,
So.
These are two southern white rhinos. Unfortunately, I couldn't get a photo where my head wasn't right in the middle, but this is one of our field rhinos, that naturally breeding southern white rhinos with one of her calves. And this was a success story for us because this is a female who had not reproduced in her entire adult lifetime, and until a person in my lab, who's a molecular endocrinologist, analyzed the diet, discovered that there were plant estrogens in excess in the diet. We changed the diet, and 3 of our 5 non-reproductive females are now reproductive.
Wow, that's amazing.
Yeah.
How many white rhinos exist in the wild now?
Well, when you ask that question, you get a lot of different answers. We do know that poaching right now has been a real problem in Kruger National Park, which is the largest collection. They think they have about 12,000 in Kruger right now. And then there are another several thousand in private hands. And then, of course, we have a fairly robust population in North America.
But we don't have 12,000 in North America.
Oh, no, not even close to that. But they do reproduce fairly well in managed care, but poaching is a severe problem. And
the genetic diversity within white rhino population do you have 12,000, which seems like a pretty big pool, but do you have to keep introducing new things into that? Well,
that's the entire pool, so there's nothing new to introduce, unfortunately, but that population did get very low at one point, down to less than 100 animals, and they were able to, with that genetic diversity, were able to balloon back up to over 28,000. So we know that was sufficient genetic diversity. The interesting thing about the northern white rhino is that in the cell lines in the frozen zoo, we have as much or more genetic diversity in those 12 cell lines in the frozen zoo than there is in the southern white rhino population. So we do know that we're starting out with enough genetic diversity in the northern white rhino to potentially reproduce that, to reinvigorate that herd.
Now, you say it went up to 28,000. How did it fall back down to 12?
Poaching primarily.
And poaching is that many? They just killed that many of them?
Yes.
Now I know that in Africa they've broken up some of these poaching rings. Have they successfully broken it up? Because I imagine most of that's going to China. Yeah, the horns.
Actually, China, the demand for rhino horn in China is going down due to education.
Okay.
The demand now is increasing in Vietnam and other Asian countries.
Looks like Oliver's just joining too.
Yes.
Hello, Doc. How are you?
Hi there. I'm good.
Welcome.
Thanks.
So maybe we should back up, Oliver. We were just talking about the rhino populations and how it's increasing in Thailand. But why? What is the frozen zoo?
Yes. What is the frozen zoo and why?
The frozen zoo is an umbrella term for a wildlife diversity bank that retains samples from rare animals mostly. And these samples can be tissues or blood, but I think most usefully to our discussion, they can be living cells. These can be reproductive cells like eggs and sperm. They can be reproductive tissues. They can be cell cultures. So these are living cells that have been grown from a biopsy and are then cryopreserved in liquid nitrogen, where they remain in suspended animation.
We've been doing this for a long time. The zoo's been around a long time. If you were there at the beginning, hasn't it been around since, how long has it been around?
The frozen zoo was started in 1975.
And were you there for the beginning?
6 months after.
Wow. And what does it look like? If I was to go to the frozen zoo, what would it look like?
Oh, it's got this techno look of big stainless steel thermoses, basically, but that are cylindrical and large, 3 feet, 4 feet in diameter, and they have a very narrow lid that you can open up and then access the specimens inside that are kept cool by liquid nitrogen.
Now, the group that was there, how old were you when you first got there? Like 10 or something?
Jesse, not nice to ask that question.
Well, I have to do the math. So,
well, very young, let's say.
I was 29.
Oh, wow. Now, what was because this is a very prescient thing to do in 1975, yeah? And in 1975, there probably wasn't even a knowledge about how important that this would ultimately become. I mean, what was the original thinking then?
Well, when I joined the research effort at the zoo, it had been founded 6 months earlier by a physician, Kurt Benerschke. And the frozen zoo was his brainchild. And he was in a cohort of investigators, medical investigators and zoologists that were interested in culturing living cells to learn more about different animals. There was a great interest, of course, in human medicine, in culturing human cells. But, immediately when the human chromosome number was identified as 46, some people wondered, well, what chromosome numbers do other species have? And so the frozen zoo served initially as a resource for answering these questions about the chromosomal makeup of other species, in part because chromosomal differences can cause sterility, famously mules, but there are many other examples. But Dr. Benerschke always felt that future discoveries and developments would make these cells available for purposes that wouldn't be obvious or we couldn't imagine at the time. And that spirit was infectious. I got it right away. And we started helping to add cells to the frozen zoo.
What kind of animals are the right animals to preserve? And do you have, you've obviously kept it going since 1975. So it must be some real, redundant systems. There have to have been storms, there have to have been things that, challenge the electricity to keep things at this temperature in that time. How have you been thinking about all that?
Well, we think about it a lot, and it has evolved. Humans have a poor record for keeping things for long periods of time. Think of the Library of Alexandria.
I lament its loss every day.
And
actually, you do.
Yeah, no, I do, but yeah.
So we wanted to be careful, but we learned, that mistakes do happen, as you say. Power outages are less of a problem for a freezer that's passive storage because the nitrogen doesn't have to be refilled on a constant basis. You unplug a freezer and it starts to warm up immediately. You unplug a liquid nitrogen freezer stays cold until the liquid nitrogen evaporates. And we have automatic freezers, but everything automatic fails. And the whole collection is duplicated. It's in 2 different locations. So if one of the buildings is destroyed, we haven't lost the collection because the material in it is completely irreplaceable.
So is one of the collections, in a very cold place so that if everything went down, it would still have a chance? Or
we'd have to be in the outer space or in a crater on the moon to do that.
Right.
There's no place on Earth that's cold enough.
Right. What's the criteria for me getting cells into there?
Well, we've developed a policy that, to try to focus on species that are of significant conservation concern. So they're species that the people in the zoo, curators or researchers or veterinarians have a strong interest in. We support those interests by banking cells. Also, across the zoo community, there are managed breeding programs called species survival plans. And these plans strive to conserve the genetic diversity of species over long periods of time. And as an adjunct to that, in support of that, we try to bank cells from these species that are under cooperative management to help assure their sustainability. And, San Diego Zoo has wonderful animal collections and very, very rare animals. Northern white rhinos are among them, but there are animals like lowland anoas or Komodo dragons or rare primates like bonobos and rare birds, extremely rare pheasants or birds of paradise that we have, and we bank their cells.
How it strikes me that the reproduction technology took a long time. The bank would have to wait a long time to catch up to where we are with the technology, and the technology is constantly improving even from where we are now. So how do you think about that?
Yeah, the reproductive technology is slow. And part of the reason for that, or the main reason for that, is the availability of samples. But also every single species requires different culture conditions. We have to understand in great detail the reproductive cycle of a female. We have to understand the physiology of their oocytes. We have to understand how to culture those oocytes to mature them and fertilize them in vitro. For example, many species can be fertilized, like humans, can be fertilized with in vitro fertilization, which is adding sperm to a culture of oocytes. In horses, and we suspect rhinos as well, because they're very closely related to horses, that technology doesn't work. We have to use a process called ICSI, intracytoplasmic sperm injection, which is taking a single sperm and with a micromanipulator and a very experienced technician to inject a single sperm into a single oocyte. And this is something that's used routinely in human IVF clinics, because so many of the infertility problems in humans are the result of poor sperm quality or very low sperm count. We have that situation also in that, for example, the northern white rhinos. We do have sperm from northern white rhinos, but it's old sperm. It was collected when the animals were old. It has been in the frozen zoo for a long time, and it's very poor quality. So we take a page from the human in vitro fertilization and infertility clinics in looking at the methods that they use for these very poor quality samples. And in fact, we're very closely connected to the human IVF world, and we collaborate with them quite a bit. So that's one of the problems, is that each species, all of these techniques all the way along, and understanding the distinct physiology of every species takes a very, very long time. And we can use, for example, for the rhino, we can use the domestic horse as a model. It's its closest domestic relative, but it's not that closely related. It's in the same order, Paracedactyla, but it's not an exact model. So we use the horse as a model for the rhino, and we hope that we can develop that technique starting with the horse. But then we know that there will be differences all along in every step of these technologies all along the way. So when we think about doing embryo transfer, of course, the end goal of the Northern White Rhino Project is to produce a herd of northern white rhinos that are self-sustaining, that are breeding naturally, that can be reintroduced into its native habitat. But to do that, we're going to have to do embryo transfer into southern white rhinos. So first we have to make those northern white rhino embryos in the lab, then we have to do the embryo transfers. There have been a few attempts in rhinos to do embryo transfer, but none of them have been successful yet. So we don't even have that technology yet, much less. Go ahead.
So a northern white rhino, to get a southern white rhino to carry that, isn't it more just then you're transferring the embryo? We think of that almost in a reductionist way, where it's just like, it's just as simple as just doing these two things. But these things have been disconnected for a long time. So how much do you have to think about how it's going to be carried, and if there's differences beyond just the genetic makeup?
That's a good question. The southern white rhino is our best hope for the northern white rhino. They have hybridized in managed care many years ago, and they did produce viable offspring. She did not reproduce, but it was probably lack of opportunity rather than infertility, but we don't know that for sure. So we do know that they're closely enough related to hybridize, and they are very closely related in some aspects. Behaviorally, they're very similar. So we feel that that is the least of our problems at this point. We have to start with understanding in detail, as we haven't before, the southern white rhino physiology, so that we can synchronize estrogen. It's also not so easy to do an embryo transfer. If the embryo and the uterus are not synchronized very exactly, there won't be implantation, there won't be a viable fetus. In some species, we know that that can be a day or two out of sync. In other species, it's a matter of hours. So we have to learn enough about the southern white rhino reproductive cycle so that we can manipulate it, we can understand it, we can synchronize that uterus with those embryos.
As we see the warming up around temperature, we're finding, a woolly mammoth, where I imagine there's cells that can be taken. We're not going to make any woolly mammoths right now, but do you collect those is that a natural thing that would go to the zoo, to the frozen zoo?
We don't have woolly mammoth cells, but Ollie, is that something that would be of interest to you?
I'm not sure we would. There have been a lot of considerations that there might be cells that survive in the permafrost, but none have really been found yet. The recreation of the woolly mammoth is a project that's intended to, provide ecosystem services in a world of changing climate, and I think that's certainly worthy of consideration, but that we're more focused on trying to prevent extinctions of species that are critically endangered at this point.
So is the mission that you have a collection of cells and animals and things that could be used for reproduction, and then you have the idea of how that would actually come into being or affect? Is it two different kinds of things?
Well, there's a spectrum on both. I mean, we're learning more about endangerment, the number of species, but the number of species that are evaluated for their endangerment is still a small proportion of all species. So we still have we have much to learn there. And then the technology for preserving species the best technology is to save species in their habitats, in functional ecosystems. But the very fact that that's a priority in the world, and nations are setting aside reserves and making efforts to do that, but in spite of those efforts, we're seeing accelerated rates of extinction, lead to the consideration that we should be exploring all options to pass a legacy of biodiversity on to the future. So there's a spectrum of assessment that needs to be done, and then there's actual collecting and the methodology for growing and freezing cells. There are species that we've tried to grow that we can't. So there's much to learn about the technology of cell culture. And then as we've been talking about, there's much to learn about the technology to take cells and produce animals out of them. There's a method of cloning, and then there's also the possibility of making induced pluripotent stem cells. These are not the similar technologies, because cloning would reproduce an exact individual. Making individuals by taking banked cells that we have in the frozen zoo and turning those into induced pluripotent stem cells would be actually producing gametes, eggs and sperm in the laboratory. And so it would be the cells who are actually having babies.
Oh, wow. Dr. Durrant, I want to just ask you, please. We learned how Oliver, Dr. Ryder came to this. What brings you to this field? Like, did you go from the human reproduction system to the animal kingdom? Tell us how you got here and joined.
No, I was never involved in the human field of reproduction. My degrees are in animal reproduction, and I was always focused on exotic animals and conservation. And so I came to the zoo a few years after Dr. Ryder did, and to do a postdoc with Dr. Kirpinurshka. And we were to do embryo transfers, reciprocal embryo transfers between armadillo species, because armadillos ovulate a single egg, which then splits into usually 4 identical twins or quadruplets. And he was very interested in twinning. And so that was a wonderful idea to do this with armadillos. Unfortunately, it didn't work. We were not able to collect embryos from armadillos very successfully. So it ended up that I didn't have a project for my postdoc, but I had remaining funds and time. And I noticed that outside my lab window was our necropsy, or a pathology group. And they were doing all the necropsies on the animals, and they were discarding testes and ovaries. And I realized that there was tremendous potential there in collecting gametes. So I started doing that and sort of going to the literature, teaching myself through studying domestic animals and humans, the protocols that they were using to freeze oocytes. Well, back then they weren't even freezing oocytes, but freezing sperm. And just started doing that, collecting those samples. And then luckily I was offered a position to start the reproductive sciences group. And I've been there ever since. But we started putting samples in the frozen zoo in 1980. And we now have about 25,000 collections in the frozen zoo, reproductive tissues and gametes of about 2,000 individuals and about 450 species. And pursuant to your previous question, certainly we concentrate on those most endangered species and collecting samples from those species where there are limited numbers. But we also have to think about collecting from species that are not in dire danger at this moment, because they will be in the future. All the work that we do with the southern white rhino right now focused on the northern white, as we were speaking just before we started today, the southern white rhino population is also in danger. So we must save those samples of skin samples, fibroblast cells, sperm, eggs, and reproductive tissues from animals that aren't endangered now, but they probably will be in the future.
What was the, impetus for working with the black-footed ferret?
Well, the black-footed ferret was a cause célèbre. It was thought to be extinct, and then in the early 1980s, a last population was found. And so, the conservation world was thrilled to see that this something that we thought had been lost was still around, but the numbers were very low. And at that time, the frozen zoo was busy collecting cells from diverse species. And I had an opportunity to talk to the people at the Wyoming Department of Fish and Game that were involved in the capture and handling of black-footed ferrets to bring some of them into captivity. And I urged them to collect some cells, and they agreed to do that. So they sent cells to us which we were able to freeze, and then the wild population of black-footed ferrets crashed. And an enormous effort has been made to conserve them by having a breeding center to reproduce animals under managed care and release them back into the wild. But all of the black-footed ferrets on Earth today descend from only 7 individuals that came out of the wild. And actually that's now inaccurate, because on December 10th was born a black-footed ferret that's not related to all of the rest of them.
And how did that happen?
Because we had the cells, and then in talking with a larger conservation community around the topic of bringing extinct species back, and the talk drifting to species that had been on the brink of extinction, a private nonprofit biotechnology organization, Revive and Restore, suggested commercial cloning, specifically a company named Viagen Equine and Pets, that a collaboration could be struck. And we got permission to proceed with exploring the possibility of using cloning technology to bring back this ferret that whose cells had been 30 years in the frozen zoo, a female who was named Willa. And now there's a young Willa, or a clone of Willa, who's named Elizabeth Ann, who has recently been introduced to the world.
And introduced to the world in that it's been let out into the wild, or it's still in the zoo somewhere?
She's far too valuable to be let out into the wild. She will be kept in isolated facilities from other ferrets, and she will grow up and see if she gains weight normally, has all of the behavioral attributes expected of a black-footed ferret. She will be paired for reproduction. We'll see if she's fertile. We'll have her offspring. Her offspring will then be used for introducing genetic variation that's been lost back into the population of black-footed ferrets. And if all goes well, her descendants will be reintroduced into the wild.
I have a question about, on this subject, to raise them in sort of isolation to make sure that they're growing properly or whatever, are we then taking them out of what that normal process would be, that they would be in the wild amongst other animals or amongst others of their species? Do we know that affects, their growth pattern or anything to do with their viability?
The viability most likely would not be significantly affected. It would be the behavioral component that would be of greatest concern. And so I'm sure that every effort will be made to raise those individuals with others of its kind when those are available, but to be raised by ferrets, not raised by humans exclusively, and given as much opportunity as possible to have normal behaviors. But as Dr. Ryder mentioned, this individual and the early clones will not be reintroduced into the wild. So when there's a cohort in managed care that can then start breeding, then those individuals then probably would be released as a cohort of similar aged individuals. I'm speculating now, but this would be the easiest way for them to grow up knowing that they're ferrets and to be introduced into a population where there are already resident ferrets. Sorry.
Was that a ferret? Was that a ferret? What was that?
No, this is a very poorly behaved dog. Sorry.
That's okay. We all have those at our house. At least I have one.
Yeah.
No Zoom session is complete without one.
Yeah.
Of course, or a cat or something.
Now, does that work take place? So you have the original collection when you collected the black ferret. Now, is the black ferret alive when it's done? When you get the cells from it, or is it passed away at that point? Like, what's the initial thing, and then is it just sent to you in a FedEx box, or is it frozen? Is it kept cold before it gets to you? Like, how does it work to collect the sample at the beginning?
The essential component is a skin biopsy, a small piece of skin, very small piece of skin, the size of half of a lentil or a grain of brown rice. But it's very interesting that one can obtain that biopsy and grow the cells even after an animal has died. If the biopsy is put in special tissue culture medium and transported rapidly to the lab. The ferrets we got initially were all alive, but we got Willa in her sample in 1988, and she had died, so that was a post-mortem sample. So we get samples of both kinds and grow up the cells and bank them.
So you get a little piece of the genetic diversity, and then you immediately grow that and then freeze it all.
Yeah, it's living cells that we grow.
Okay. And how long? Go ahead.
We also can collect sperm and oocytes post-mortem and from living animals. Post-mortem oocytes are problematic. They don't survive as long as the skin cells that Dr. Ryder was talking about, but we can collect those post-mortem as well. And they're sent in a specially designed kit that we send out to rhino zoos that hold rhinos. And we're working with partners in South Africa to collect oocytes from living and postmortem animals, and we have helped to set up 2 laboratories there that are doing the same kinds of work that we're doing here in San Diego. But in South Africa, they have access to a much greater number of southern white rhinos than we do here in the States.
Is there, in Kruger, you're talking about part of it is in South Africa, the other side of it is in Tanzania. So it's like, where do you go to start getting samples? Does that all become an issue, or is it all just fine?
We're working with sand parks, and so we're working exclusively at this time with South Africa.
Mm-hmm.
Unfortunately, in Kruger, even though poaching is now out of control again in Kruger National Park, and we would think that might be, unfortunately, a rich source of skin samples or oocytes or even sperm. But by the time the Kruger National Park, of course, is very extensive, very large. By the time the rangers find a carcass or know that an animal has been poached, those tissues are usually too degraded to be useful for these purposes.
How long can the cells survive in the bank?
Theoretically, indefinitely.
Oh, wow. Okay. So once you start duplicating them, do you have to duplicate them every so often, or does it not matter? They're just frozen and they stay frozen and they stay healthy?
Dr. Ryder can answer that about the fibroblast cells. Our cells, we don't duplicate, of course. Germ cells, once you take them out of the freezer, you use them. You don't duplicate them. But Dr. Ryder can talk about the fibroblast cells.
One of the interesting attributes of the fibroblasts is that you can expand them. You've started them from a small number of cells. You've taken, there are millions of cells, really. You've taken in a biopsy, and we grow them up and freeze a number of vials. And we can take out one of those vials years later, for example, 30 years later, in case of the ferret, and grow up more cells and bank more cells than we actually took out. So it's an expandable resource. We have not detected any difference in viability or growth characteristics of cells that were banked 30, 35 years ago. The trajectory for their viability is centuries or millennia.
The Przewalski horse, that's a population that was sort of bred during World War II, right? So how do you think about this particular animal?
Well, Przewalski's horse, the first captive breeding took place in 1902, something like that. So there's a long history, an exciting discovery of a wild horse in Mongolia that excited the world's attention at the turn of the 19th century. They became extinct in the wild and were saved by zoos propagating them. Over the years, we have saved in the frozen zoo samples from hundreds of Przewalski's horses. So we have a good representation of the gene pool. And although we don't have any animals that were unrelated to the current population or were brought out of the wild, over time, the managed population of Przewalski's horses has lost genetic diversity. And so by banking the cells of individuals earlier in the pedigree, we can restore genetic variation that's been lost. So we can ameliorate the slow erosion of genetic diversity in a population if we can use these cells to make animals. And has recently been shown, again, in collaboration with Revive and Restore and Biogen Equine, a Przewalski's horse has been cloned.
Now, that horse lives in Mongolia and in, I'm going to say, Russia, someplace like that, right? So how do you, or I forget, there's two populations, right? So my question to you is who funds because I imagine that's an expensive proposition. So how do you find funding to save that horse, the genetic diversity of that horse?
Well, many aspects of that horse that require funding. There's a population that are bred and maintained in zoos that have the genetic diversity, all of the genetic diversity. A subset of those animals have been released into the wild in China and Mongolia and Russia. The national pride at bringing back a species that's part of their heritage helps fund this, but it is expensive to transport animals by air. But zoos have contributed funding to this and nonprofit organizations as well.
When you started, both of you early on, did you realize how important the zoo would become, how important the frozen zoo would become to these conservation efforts?
Yes and no. I can say for myself, yes, no, yes, in the sense that, cells are amazing, the things that they can do, but, would we ever be able, because we had banked them and could be able to keep them alive and grow them, would we ever be able to have them recapitulate all the things cells can do? And that was something that was hoped for. But there's some experiences that are going to be dramatic and impactful, but you don't know what it's like to have that experience until it happens. And so, as much as the potential of the frozen zoo was in our minds and prescient, the impact of seeing an animal that was produced from a cell that we banked 30 years ago, or one of the Przewalski's horse samples that was routinely collected as part of an effort to bank genetic diversity, to see that come to fruition is an astounding experience.
Dr. Durrant, what about you? I'd love to hear your thoughts on this.
Yeah, and Dr. Durrant, the original the original doc that you both worked with in the beginning, what do you think they would think of where you are today?
Well, I think for me, saving those samples of germplasm, sperm, eggs, reproductive tissues was more direct. I could see the potential more directly than perhaps back then we could see the potential of those fibroblast cells, because the technology to use those fibroblast cells now that we have now was not in existence at that time. But certainly in vitro fertilization and embryo transfer was something that was done in the mostly domestic animal world, beginning in the human world. And so I could see a more direct effect. I could see a future where sperm and eggs frozen in the frozen zoo would be combined to create embryos, because that was a technology that, although not used yet for any exotic species or any endangered species, is certainly what the techniques, the principles were being proven in domestic livestock and in humans. I think that as we know from Dr. Bernarska, he loved the quote that we must collect things for which for the uses for which we don't yet understand. So he had that vision that this was important to do, and knew that there would be techniques and technologies that would develop in the future. He didn't know what they might be, but he knew that there would be uses for these things. And if we didn't collect them at the time, we would never have them. So the idea of genetic diversity, collecting and saving genetic diversity, regardless of the potential future application, was in his mind when he started the frozen zoo.
Do you think about the ethical consequences of this and how it could be that you're all doing it with an incredibly pure reason? Do you think, you said you do exchanges with human, reproductive centers. Do you think of the crossover on just this science itself?
As far as ethical considerations are concerned, for us, the ethics are that we must do this. We have an ethical responsibility to do this, to save the genetic diversity and to utilize it. It's not enough to put these samples in the frozen zoo. They have to be utilized to be of any value to the populations. As far as any crossover with the human world, we have had nothing but very positive relationships, and we get support, not only intellectual support, but financial support from people who work in the human field, who are sort of at the forefront of developing some of these technologies, because they have the numbers, they have the equipment, they have their patients pay for their for their procedures, and they pay very well. So they support us. They understand why it's important for us to do this with exotic species. Of course, the livestock industry has been doing this for 30 or 40 years or even longer. That's a commercial aspect. We don't see a commercial value in what we're doing at all. It's simply a conservation. And when you ask about ethics, it's interesting that you ask that. To us, it is an ethical consideration. It is what drives what we do. We are responsible, we as humans are responsible for the situation that we're in now with so many species extinct or going extinct on our watch. We're watching the last northern white rhinos. As we speak, that species or subspecies is disappearing in front of us. And that gives us an opportunity, unfortunately, an opportunity for the world to see. The northern white rhino has been very highly publicized. Many people around the world understand the plight of the northern white rhino and that this subspecies is going extinct. That gives us an opportunity to say, it's time for us to do something. We can make an example of the northern white rhino. Luckily, we have the southern white rhino, which is very closely related, and we can utilize the southern white rhino as recipients for northern white rhino embryos. But it gives us an opportunity to develop the technology, to get funding to develop the technology, and also to show how science supports and advances conservation.
You know, it's an amazing thing that you've both been a part of. How important is it that this thing, this frozen zoo, continue as an institution for the next 100 years after you guys, you know, I'm assuming you won't be there in 100 years, or us for that matter.
Beyond 100 years.
Yeah.
We hope the world is around, so it's no way. Let's look 1,000 years.
Yeah, I mean, with these climate, you know, the existential threat of climate, you know, how important is it that we protect this institution and treasure it?
It's absolutely essential, and not only for our frozen zoo, but for the development of frozen zoos around the world. One of our goals for the frozen zoo is to spread the technology to help with protocols, with techniques, with financial support, with expertise for other countries, especially those that are biodiversity hotspots like we are here in Southern California, to develop their own frozen zoos. We cannot do it all ourselves, but we need to promote the idea of frozen zoos around the world. And we're engaged in that activity, but it can't go fast enough for us. But it certainly is going to be ever more important for most countries to have their own frozen zoos.
Wonderful. Thank you guys so much for spending time with us today. This was really incredibly insightful and deeply appreciated.
And if people want to know more, where should we direct them? You know, the audience, where should we send them to kind of learn more about you? Is there a specific place?
Well, you can start with the website, San Diego Zoo Wildlife Alliance, or sdzwa.org. And also there are a number of publications that are available.
Thank you so much. This has really been insightful, and we deeply, deeply appreciate your time.
Thank you.